This is an asteroid that some of you may have heard of, 16 Psyche. It's suspected to be on a planet's core that became exposed after constant bombardment billions of years ago. But fast forward to today, and it's mostly known for its metal, which if you compiled and put here on Earth, would be worth many times the world's entire economy. In this video, we're going to go deep into how asteroids like 16 Psyche came to be, the logistics of mining asteroids, and when we can expect one of those guys to be in our smartphones. Part 1. The science. Before we go scouring the solar system for asteroids we can tug home in mind, we first need to know a few key defining factors that make an asteroid that can make us money. There are 3 rough classes for asteroids in our solar system. First, C-type for Chronodite. These common asteroids have a lot of clay and silicate rocks, the same ones that make up the majority of Earth's thrust. Then there's S-type for Stony. It consists of more silicate rocks as well as nickel iron. And finally, M-type for metals. These asteroids are the ones we're looking for. These are 60% iron nickel, but with the other 40% consisting of things like gold, silver, and platinum, with trace amounts of just about every metal you can think of. These compositional differences occur primarily because of the different melting points of different materials. If an asteroid formed too close to the sun in its early lifespan, valuable materials could partly melt and subsequently sink back into the core, being replaced by volcanic lava at the surface. In the intro, I referenced 16 Psyche, and I want to touch on that asteroid again, because it might not be that at all. There's some evidence that 16 Psyche was the core of a protoplanet many billions of years ago. It then got stripped of its surface via a large impact or many medium-sized ones. This will be a key part of NASA's mission to visit the asteroid, in which the probe actually has equipment that will try to determine if this is true. Cores of planets are very heavy and dense with materials, but they're also little gold mines for science, because we can't dig to the core of our planet or any other one. The deepest we got was the Kola Super Deep borehole, which over 20 years of excavation only got halfway through the crust, and absolutely nowhere near the core. Part 2. The logistics and ethics of mining asteroids. Unfortunately, the only way we currently have of harvesting rare earth minerals is, well, digging the earth. That's why in the future it'll be key for the environment that in-space mining can be set up and the destructive nature of mining can be taken to other places. We'll talk about the ethics implications of that soon, but if that was out of the way, how would we do it? If asteroid mining takes off as quick as general spaceflight has been the last 10 years, we're going to need to get a few things straight before we can start launching parts. The first thing will be to determine our targets, as the location of the asteroid massively changes the amount of delta V necessary for getting it. While the main asteroid-bound destinations like 16 Psyche would be a long-term goal, it's not realistic that we could achieve that very soon. Instead, we still have quite the selection down here near Earth. These appropriately named near-Earth asteroids are ones that coincide with our orbit and therefore, if timed correctly, would make a very good target for an early mission. Once you've found yourself at your asteroid destination, there's 2 things you could do to harvest it. Either assemble a rocket/station that moves around asteroids, harvesting them as they go and sending the valuables back to Earth via smaller pods, or you can make a much larger forge in low Earth orbit and take the asteroids to us. I'm going to focus on the latter as it's more feasible for early game space mining. First, a large tug ship would be sent out to a near-Earth asteroid, consisting mostly of one large strong plate used for the direct pushing of the asteroid, and then a vast network of ropes that would be used to keep the asteroid stable on its journey. Anyway, once it's snug in its little enclosure, the way back to Earth would be calculated, and it would generally only take a few minutes of burning the engines to get it on a long orbital path back to Earth. Once in low Earth orbit, please be careful making sure your asteroid doesn't drop back to Earth and do the dinosaur thing all over again. But once that's all sorted out, hook it up to an in-orbit forge. The main component of this are main mirrors that focus the sun's light onto your asteroid, where the now melted metals are transferred up into a processing part and shot back to Earth in little re-entry pods, probably directed for a designated collection point. So wow, it's easier said than done, but that's the outline for space mining. And now we'll look at the ethical problems for doing this. Many of the asteroids we'd target would be billions of years old, and each with their own snapshot of solar system history, it would be pretty tough to tear them apart. I'd like to compare this to seafloor mining, a new technology that's quite controversial in the terms of protecting the ecosystems down there. The nature of mining is so that anywhere it is, it's going to mean damage, and unfortunately, that's going to impact our asteroids. 3. When? Finally, we'll take a look at when we can expect the materials gained from the solar system to be in the machines that we use every day, like the microphone I'm using to record this. My estimates would be that we see trial testing quite soon, large probes that would take a few tons of asteroid material within the space of the next 1 to 2 decades. This kind of thing would be possible with the SpaceX Starship. However, for it to become mainstream, I think it takes so much infrastructure and technological gain that we'll probably have to wait until the turn of the century to see it replace terrestrial mining. Maybe I'm pessimistic or optimistic. You guys, by all means, rip loose in the comment section below, but as for me, that's all. If you subscribe now, by the way, you'll be my 82nd subscriber. That's all up to you guys, but thanks for watching and have a great day.